Alright, so let's go through the checkpoint 13. A student construct a transformer that has 1000 turns on the primary coil. He then construct a second transformer identical except that it has an additional 1000 turns on the primary coil. So meaning initially is 1000, so this is the first transformer. Second transformer will have 2000 turns, because 1000 plus 1000. So both transformer may be considered ideal, meaning no energy loss. So both are operated with the same input voltage, providing the same output power. So of course, think of it as, for example, this 1 volt, this also 1 volt. Okay, how do the output voltage and how do the output current of the second transformer compared to that of the first transformer? Okay, so first, for this type of question, you can actually put in numbers to help you. So for example, the first transformer, I just think of it as 1000 on the primary coil. And then of course the secondary coil, maybe I put it as 4000. Meaning that if let's just say my input voltage, this is your input voltage, to be 1 volt, then your output voltage, which is right here, will be 4 volts. Because you just use the ratio, right? So for example, let's just say I use NS over NP is equal to VS over VP. So this will give you 4000, then this will give you 1000, which is just 4000 divided by 1004. Then after that, VS, I don't know, or VP, I put as 1. So eventually you will get 4 volts to be the output voltage for the first transformer. Okay, what about the second transformer? Second transformer, same input voltage to be 1 volt. But your primary number of turns, right, is about 2000 turns. Then your secondary, right, because they are the same. So this 4000, this must also be 4000. Meaning that the output voltage will be 2 volt. Because 1 times 2 is 2 volts. So of course, looking at this, you can actually compare. So they want to compare what is the output voltage of the second transformer is to the first transformer. Oh sorry, I highlight wrongly. So this is the second transformer, 2 divided by 4. So it's about half. So the answer is either A or B. So of course you can use any ratio, number of turns for the secondary coil, you'll get the same result. Okay, what about the output current? Okay, output current, you can also do the calculation. For example, right, the first transformer. Okay, first transformer, same thing. I may just maybe use 1 ampere for the first transformer. So NS over NP, right, is equal to IP over IS. So NS, let's just say, NS is your 4000, right? Then your NP is 1000. Your IP is 1 ampere, because I set to be 1 ampere. IS, I don't know. So you do the calculation, apparently, right, you will get something like IS to be 1/4 ampere, or it's as good as saying 0.25 ampere. Okay, what about the second transformer? Okay, second transformer, same thing, 1 ampere. So everything 1. So NS over NP is equal to IP over IS. So NS, right, is 4000. Then your NP is 2000. So 4000 divided by 2000 is 2 already, right? So IP 1, IS I don't know. So IS, you just use the ratio, right? So it's about 0.5 ampere, right? So you simply just use 0.5 divided by 0.25. So this will give you 2. So the answer will be B. Of course, you can try to use other ratio. You will always get the same ratio one. So you can use, for example, let's just say the first transformer. Instead of stepping up, you can actually maybe use 500 turns for the secondary coil and 500 turns for the secondary coil for the second transformer. You will still get the same result, right? So that is how we do the checkpoint 13.